I want you to pause the video and write down the system of equations, and as it says here, solve the following system of equations using the Gaussian elimination method. Okay, finished? Alright. What did you get for x, y, and z? And of course, it's important that you know how to do it. Even if you don't, you may have made a mistake and got x, y, and z has a different number from what it really should be. Right? You should know the method that you should use. Alright, so what we do is to rewrite these in matrix form. So you have a 1x plus a 1y plus a 1z equals 4. You're going to have a 2x plus a negative 1y plus a 1z equal negative 3. So let's say I didn't say minus a 1y, now I say plus negative 1y. Because the default operation is addition, your plus. But when you say plus negative y, when you say minus y, it's the same as plus negative y. Alright, so you have a 4x plus a 3y plus a negative 1z equals 3. Then you write it in augmented matrix form. Remember, you could have written it like this first, where you have these in brackets, just like when you're doing the inverse matrix method. You could have had it like this, no problem. One equal sign would be here. But when you write it in the matrix form we're going to look at, you don't want the x and y's and the equal signs to be there. You want to make it look very simple. So what you do, you have everything in a bracket. When it comes to the equal sign, you remove those and just put a vertical line. Alright? So what you have is the augmented matrix. And they say the word augment means to express something in a more elaborate manner, or whatever you want to call it. But what happened here now? What we want is to have a 0 here, and we want to have a 0 here. Having a 0 here means that you eliminate x. Your problem is you have 3 unknowns. You don't know x, you don't know y, you don't know z. Because remember, this is in the same format, you know. It's 4x plus 3y plus negative 1z. You don't know x, you don't know y, you don't know z. If you should eliminate x, there would be a 0x here, but you still have 2 unknowns. You originally have 3 unknowns. You don't know x, y, nor z. If you eliminate x, you'd have a 0 here. You only have 2 unknowns, but that wouldn't really help you much. If you eliminate 2 unknowns, eliminate x and eliminate y, you have 1 unknown, z. So you could find z. When you find out what z is, you put it here. But you would have 2 unknowns here, x and y. Guess what? You put a 0 here. So here, whatever z is, you put it here. X is eliminated because you have a 0 here, so you have only 1 unknown, y. So you found x and y. So all you do, put it up here. You know your z I mean, you found y and z. You put it up here, you know your z, you know your y, but you don't know your x. One unknown. So you can solve it that way, alright? So let's try and get a 0 here. One strategy you could use. Remember, it's really simultaneous equations, elimination method. If you multiply this by 4, you're going to get some 4 somewhere. And then take this 4 and subtract them. And the new numbers, you replace them in row 3, and you get your 0 there. So that's what's going to happen. Now this is row 1, row 2, row 3. Alright? Going across. Alright? So, here, what we can do is change row 1 so that you have 4s across. So, alright, let's not change row 1. We could change row 1 to show the working. But we're only going to change row 3. So row 1 is 1, 1, 1, 4. We're not going to change row 2 either. It's 2, negative 1, 1, negative 3. We could have changed row 2 if you want, because if we multiply this 2 by 2, we get a 4, and we could subtract these 4. Right? Could have done that as well. But we want to change row 3. How are we going to change row 3? We're going to say row 1 times 4. So let me write it this way. Row 1 times 4. When we have row 1 multiplied by 4, we're going to say that minus row 3. Right? Row 1 times 4 minus row 3 will give us our new row 3. In previous videos, I would have put the arrow to the right and say our new row 3, but I just feel like putting it this way here because it's pointing to the row 3 that we're dealing with. Right? Could write it this way, but the general way I see them write it is to put this to the right. I don't really want to violate the general method of doing it. But this is our new row 3. Alright? Our new row 3 will come from here. Alright, so what happened now? Row 1 times 4 and minus row 3. Row 1, 1 times 4 minus row 3 here, minus 4. Is 4 minus 4 is 0. So you have a 0 here. See that? After that, row 1 times 4 minus row 3 again. Alright. So row 1 times 4 minus row 3. But what is in row 1? Row 1. Oh, I remember this one's going across. This one's going across. So it's 1 times 4 minus 3. This 3 here in row 3. 4 minus 3 is 1. So it's a 1 would come here. And then for this now is 1 again. Row 1 has a 1 times 4 minus row 3. Row 3 has a negative 1 minus negative 1. So it's 4, 1, 4 plus 1 gives you 5. So 5 would come here. See that? And then row 1, in the fourth column, row 1 has a 4. So row 1, 4 times 4 minus row 3. What was row 3 again? 3 minus 3. It's 4, 4, 16. 16 minus 3 is what? 13. So it's 13 would come here. Alright? So here, you got a 0. Now, what you want to do next is to get a 0 up here. Because the thing is, if you put a 0 somewhere else, like here, you successfully get a 0 here. In order for you to do that, you could say row 1 minus row 3. 1 minus 1 will give you a 0 here. But guess what to that? 1 minus 0 is 1. So it would give you back a 1 here. So if you have a number, other number over a 0, there's a danger that you might add or subtract that number with the 0. And the 0, you lose the 0. You don't want to lose the 0. What you do? Put a 0 up here above this 0. So that no matter what you multiply the zeros by, you get 0. No matter how much time you add or subtract them, you keep getting 0. So to make the 0 safe, put a 0 up here. Alright, so how are you going to do it? Let's rewrite row 1 and row 3. We're not going to change those. We're going to change only row 2. So row 1 is 1, 1, 1, 4. Row 3 is 0, 1, 5, 13. Alright. Now, another way I see them write it is to say this. Row 3 will be obtained from what? It's going to be, it would be, what would you do now? If you multiply row 1 by 2, and then say row 1 minus row 2. Right? So row 1 times 2. Sometime I see them write 2 row 1 instead of row 1 times 2. Right? 2 times row 1 minus row 2. I write 3 there. Minus row 2 will give you row 3. Now, I like having it like this. I put this nearer, and then the arrow point to the new row 2, right? So you have 2 times row 1. Alright, so row 1 has a 1 here. 2 times that minus row 2. It was a 2 here. 2. 2 ones, 2 minus 2 was 0. So a 0 would come here. See that? Now, here, the next thing, 2 times row 1. You have a 1 up here in row 1. 2 times 1 minus row 2. You have a negative 1 here minus negative 1. Going to be 2 times 2 plus 1, which is 3. So a 3 will come here. Alright? What else will happen? 2 times row 1 is a 1 here. So it's 2 times 1 minus row 2. Row 2 minus 1 minus 1. 2 ones, 2 minus 1 is 1. So you have a 1 here. Alright? And then what happens after this? There's a 4 up here. So it's 2 times 4 minus, and then you minus row 2 with a 3 here, with a negative 3, so minus negative 3. So it's 2 4s, 8 plus 3, 8, 9, 10, 11. So you have an 11 here. Alright, so that's what you have there. Let me just erase this thing here. Rough work. So now, The thing is, you have eliminated x in equation 3, represented by row 3. But you still have your y and z, and the same thing happen up here. So what can you do? Alright, the traditional next move is to have a 0 here, right? You could cause a 0 to come here if you want, but the usual way is to make the 0 here. So what you do, let us make changes to row 3 alone. So you rewrite row 1, rewrite row 2 as it is, and then change row 3. How are you going to change row 3? You get the 0. What you do, you say multiply row 3 by 3, and then what you get, you subtract, so you minus row 2, alright, to get your new row 3. So remember, you can always multiply a new, you can always multiply an equation, in this case a row, by a number, and you can always add or subtract equations, add or subtract rows. Alright? Remember, the rows represent the equations. It's just that you're not seeing the x, y, and the z. Right? Now, here, you're going to say 3 times row 3 minus row 2 will give you the new row 3. Alright? So, 3 times row 3, 3 times 0, minus row 2, minus this 0 here. So you see the zeros are safe. Both these zeros are quite safe. Can't do anything to them again. No matter how much you multiply numbers, no matter how much you add or subtract, row 2 and 3, those zeros are safe. So 3 0 minus 0 is 0. Alright? So the next thing here is to say 3 times row 3, which have a 1 here, 3 times 1 minus row 2, which have a 3 here, 3 times 1 minus 3. 3 by 1 is 3, 3 minus 3 is 0. So the new row 3 has a 0 here. Nice. Which is what you wanted, right? 3 times row 3, so it's 3 times 5, 3 times 5, minus row 2, which is 1, minus 1. 15 minus 1 is 14, so you have a 14 here. See that? Then 3 times row 3, you have 13. So 3 times 13 minus row 2 minus 11. It's 11 here. So 3 3s, 9, 3 1 3. 39 minus 11 is what? 39 minus 11 is going to be 28. 28 would come here. Alright? So that's what you have here. So let's rewrite 1 1 1 4 0 3 1 11. By the way, we can get smaller numbers in row 3. So we say half, if we half everything in row 3 to give our new row 3, what we have, half a 0 is 0, half a 0 is, no, not half. When I say half, you divide by 14, 1/14 of row 3. Or we could say row 3 divided by 14. 14 over 14 is 1. 28 over 14 is 2. Nice. So we have smaller numbers here. All right. Now, what we have here can be used to solve our equation, right? You can go ahead and solve it. Now, if you were to write it in what they call row echelon form, you would divide row 2 by 3 to get a 1 here. Just that you'd have 11 over 3 here as a fraction, right? But anyway, we go ahead and solve by rewriting all of these back in equation form. So it's 1x plus 1y plus 1z equals 4. That's equation 1, row 1. Come from up here. Next is going to be row 2 from here. 0x plus 3y plus, look here, it should be 1z. Yeah, plus 1z. I'll just write a line across my z, because if I don't do that and lose concentration, I will start writing it and it starts looking like 2 instead of z. Alright, equal 11. So that is equation 2. Equation 3 coming from row 3 is 0x plus 0y plus 1z equals 2. Alright, that's what we have made it from. What is 0x and 0y? You don't need to see them. So it's 0x and 0y. So all you need to see is this. So from this, we know that z is equal to 2. Alright? From here, z is 2. Now here, 3y plus z, but it's plus 2 equal 11, because you know z is 2 already. So what you have is 3y equals, subtract 2 from both sides, 11 minus 2, which is 9. So y would be 9 over 3, which is 3. So y is equal to 3. Alright? And after that, we'll want to know what x is. Well, let's put the z to the right, so that we have x, y, z going from left to right. Alright, good. Let's erase this to make space. What happens next? We have x plus y plus z equal 4. So x plus y plus z equal 4. Alright, we know that z is 2, so this is 2. Y is what now? Y is 3. So we have 3 here. Nice. So 3 and 2 is what? 5. So x plus 5 equal 4. And then x equal, we subtract 5 from both sides. 4 minus 5 is negative 1. So x equal negative 1. Nice. So that's what we have.